for the delay. Very great introduction. I have to live up to the expectations in the presentation now. So yeah, we'll be talking some interesting stuff, and I think the next these 3 days you're going to listen a lot. Perhaps this will be something slightly different from what you listen in other presentations. So this was on our annual report last year. We reached the moon, Shiv Shakti point, right? One of the hallmarks. Let me dive right into it. Okay, let's. Yeah, so I am Nitish Kumar, and already there has been a very great introduction. So I'll be talking about some of the AI applications that we try to do. Obviously, for obvious reasons, I cannot explain all the details of the missions that we do, right? I'm not the official spokesperson for ISRO. However, what I wanted to share was some of the experiences that we had and some of the indigenous Indian AI that we developed and the challenges, and it's very interesting how we solve certain problems. So it's kind of going to be a story, kind of like short stories. Yeah, okay. So we basically do a lot of things for the government, including, communication services, weather, cartography, education, and healthcare, disaster management, and we also do some spin-offs. So there is a lot of things that ISRO does at different levels, and there is a lot of appetite for automation. In space, automation, is very, very prized. It saves a lot of money. It improves the quality of the mission, the amount of science you can do in space. So for us, AI is very relevant. Now let's look at some of the areas, okay, yeah, where AI can be applied at ISRO. So obviously launch operations can be highly automated. They already are automated, by the way. And I think every generation has its own definition of AI. So there were AI scientists even a generation before us who were thinking, and rightly so, that they were working on AI at ISRO. So the definition of AI is changing a lot. So what we call as machine learning and data-driven AI is something that has taken off after the big data revolution that has happened, right? Before that also people were working on AI. So we do a lot of AI in launch operations, in spacecraft health monitoring. This I'll discuss in detail. We have a lot of interplanetary missions where we apply partially some AI. And obviously GYAAN mission, the human spaceflight mission, has a lot of appetite for AI because we are putting a human, and a lot of operations can be assisted, can be automated with AI. Okay. Some of the things that we have already done with AI, and which I have done actually, some of the things is here. One of them is inspection systems, and I will discuss one case study there. And checkout basically is checking out a spacecraft or a space system before it is actually launched, right? And it's very complex. So we are trying to automate that. Earth observation is somewhere we have done a lot of automation, which is basically satellite imagery to data intelligence, basically input to the government. Let's say for agriculture, we want to understand something. We have a lot of cartography data, a lot of Earth observation data, and we convert that into insights, right? Something to look forward to in next coming years, swarm satellites, which means a group of satellites operating together as for one goal, a swarm of satellites. Docking experiment, I think recently we were successfully docked the first set of satellites, SpaceX, humanoids. So yeah, I think you get the picture. So let me talk about AI, and let us talk about how we at ISRO look at AI. So we first of all question what is intelligence. Very, very difficult question, not in our domain, right? And also intelligence is very relative, right? You feel more intelligent when someone not so intelligent is beside you, right? So very difficult to define intelligence, kind of relative. Also, what are the steps in which we can break down intelligence, right? Any automatic agent or autonomous agent, right, has to do these three things. So first of all, it has to sense something. Then it has to process that something, think about it, and take some action. So these are like essential steps. Now, very interesting is the story of AI development so far is actually along these lines. So you would have seen in 2011, 12. So I'm working in AI, by the way, when nobody was working in AI since 2013, 14, right? And we thrown out of a lot of meetings for something that was very futuristic at that time. Now, of course, it's very relevant now. So we started with computer vision and some initial data, data handling, you can say, kind of very intelligent data handling. So that was perception, getting sensor data, vision data, or any other kind of data, and just understanding that data to a certain bit. Also, computer vision itself is a cognition process. It itself is an intelligent process. So it also has certain, cognition and action also. Like classification of an image can be an, the final answer is action. But in general, it's more perceptive. And that's why computer vision is also more reflexive. You don't get a lot of explainability. It's not very expressive. Like if you look at CNNs and so many DNNs, right? These are not very expressive. So I would say that this is more like perception and then cognition. So cognition, we started with like data analytics was the like very small step towards some analysis of the perceived data, right? And then today we have like semantic, which is basically all the LLMs, like they don't understand things at the bit level. They understand things at the semantic level. Like you do a RAG, you do a semantic search. LLM produces tokens with a semantic understanding. So this is like and now there are a lot of talks about conceptual understanding, like whether an LLM can think the way we think in terms of concepts, right? So what is the concept? Like I am able to speak to you because you guys already know a lot of concepts that I'm just triggering through my words. Like those who don't know the concept will not understand what I'm saying. That might be quite a lot of people here in that domain. But anyway, and then multimodal, right? Multimodal is again when you are able to handle all sorts of perception in different forms and combine them together into some analysis or decision. And then obviously action. Now, I think we are very good at perception now today. And the limit of this is sensors. Like Tesla can become much better if we have much better sensors. Because human body has amazing sensors, by the way. So most of the fight is still here, I feel. And then cognition. Cognition, we have done a lot of development in the last 2 years, especially after 2016, attention is all you need paper. And then in action, last year there was a lot of talk about language action models, if you guys have heard. There's a lot of talk about that mobile phones, you need not press any key. But somehow, it has not gone so far. But Gen AI is kind of very expressive. It takes certain actions, it gives you output. It is doing something, it can do something, right? So I'm placing it there, and robotics is definitely the next future, if you ask me, is going to be robotics. Because I have a lot to talk, we are done with the basics. Let me take you to the first case study that I wanted to show you guys. This is more about perception level, right, that I talked about. So this is something that flies in space. So this is a solar cell, which is, welded in our lab, and then it produces energy for the satellites. This is very, very critical because it has to survive in the space conditions for 15 years. And we hope for like 22 years at least. So our tech due diligence on this, our inspection process on this is very, very strict. So if you apply any normal, even today's latest algorithms, if you apply, you can get like 99.99% or something, and that is not acceptable to ISRO. So for me, it was very difficult to go to these meetings and present this and be like, we can do one mistake in 1,000, and they were like, just get out. You cannot do that, right? Because we put like thousands of cells on one satellite, nearly 14,000, 15,000 cells on larger satellites. So that's not a good number. They were not happy with it. So they gave me a number, by the way. It was 1 in 10,000, you can do a mistake. That's 99.99. So I had to live with that, and it was around 2017, and AI was not at the level it is today. So yeah, so just wanted to share this experience, horrible experience at the beginning. And then from there we thought, okay, what we can do. So which approach to use for classification. So one thing I want to tell everybody, and one of the reasons I came here is talk to all the developers is, in software development, I feel India has produced great amount of software, great developers, but we did not produce great softwares, right? In AI, I wish that India does not do the same mistake. I don't want all of you to become just AI developers. I want you to develop AI. Okay, so that is the call for which I want to give this whole talk. And this was the moment actually that we think what we can do. We can study a lot, and all these methods don't work. So this was actually a boon in disguise because it started our getting our brain activated. So we thought, okay, we have to do something like which is more human understandable, reduced abstention rate, better training measures. So this was something that we had to achieve. So let me tell you how we achieved it. Pretty simple at the end, but it took kind of 2.5 years to get here. every day for 2.5 years. Okay, and so one of the modules that we use is the latest YOLO thing, right? But this is not critical. Like we just use it so that people can see where the crack is. Only for that. This is something we developed on our own. I guess this is a pointer. Okay. Anyway, this URSC symbol is something that we have developed and patented. And we have LSIS2 module which is trained over all the images. So basically LSIS2 is a CNN. This is our explainable algorithm that runs here, and it uses the CNN, by the way. And this is object detection module, and we get an ensemble based decision in which these two modules are only used for decision making. And our accuracy has reached, like till now we have not have a fault, by the way, and it's been 8 years. I think that was clappable. So how did we do it? Very interesting story, and I'm going to tell you more about the thinking part, right? This is SHAP, by the way, like people who know, right? And SHAP gives you a state of the model, right? And SHAP was coming out, still developing at that time, kind of. Actually, this idea came from a philosophy book of Parmenides, which I was reading at 3 a.m. in the night. And that is one of the points I want to tell the people, that AI solutions don't lie in AI books. Okay, I got the idea from Parmenides' philosophy, and there was a line that which is not cannot be, right? Which means basically if something does not exist, that is a unique state. You cannot think of it. And that is similar concept in Vedic philosophy also, that when you do GYAAN, it is actually not presence of something, it is actually absence of everything else. So that is a singularity. So zero state, absence of anything is a singularity. So that was something that comes from philosophy. And then we use that here so that if we don't have a crack, right? If you are able to create a good background in SHAP, you actually have the model looking for something and not finding it. So it is like similar to someone saying, look there, and you are not able to look at that thing, right? And you just keep on shifting your eyes, not able to lock on to that thing, right? And we use that. We use that idea that if there is absence of something, that is a singularity. And the entropy, we came out with our own unique value, which we call as XCV right now. So what that does is, it is highest when there is absence of any feature. This Google has not done, Meta did not do, right? And they have like billions of images. And we did this with around 10,000 images. So what we do is we not only listen to what the model has said, right? And model can go wrong sometimes. Despite being trained, you can do as much as you want. But we don't rely on the model output anymore. We also look at what is the XCV value, which is kind of an entropy value. And it is very high if the cell is okay. So we have 100% accuracy if the cell is okay. So that means if I say that some cell is okay and it can fly, that will never be wrong, right? And that was what was required. So we came out with this. It solved a lot of problems. And I put this just to show that the path was very difficult, right? It was not great and smooth. And it also solved all the problems that we have. Model reliability enhanced. Also, one amazing thing that we have done is, when you train a model, generally you don't know how well it is trained, right? You have certain parameters, overtraining, overfitting, and knee curve and all that, but still it is not great. So let me show you. This is the outcome of that concept. When you start with the model and it is not trained, both the classes are mixed. You can see the normal and fractured, or and as you train, they kind of get separated. And as you train further, the kind of class distinction is very high. And you also know what is a threshold. This again, nobody has developed. Meta, Google, nobody so far. So with this concept, you are sure what is the threshold value for you and whether you should train your model further or not. Very explainable, very visual, very simple. So it can be used in a lot of areas. I have less time, so I'll just skip forward. We are using it, by the way, medical. We have tested over X-ray images, and it's working great there also. Second thing. Let me tell you a bit about the story. We have 57 satellites orbiting us right now, and there are people who monitor the satellite telemetry coming day in, day out. It's like round the clock over the years. So we thought of automating it. Again, it's very difficult. There's so much data coming in. There are so many things involved, right? And a satellite may have around 15,000 to 20,000 sensors. So it's very difficult. And the task given to us was forecast anomalies early. And you can't just send a wrong signal to ISRO scientists at 2 a.m. in the night, saying that, oh, sir, it was a false alarm. Right? So you have to be very, very accurate. We have to be very, very accurate. When we say something is about to go off, then we pray that, okay, this should go off, right? Otherwise, I'm going to have a very hard next day, right? But anyway, cutting the long story short, we came out with something called as MEND architecture. So in this, we worked with IIT Kanpur. Now, already, and I think this was one of the very significant advancement for us, was we were able to detect 20 to 30 timestamps in advance. Our timestamp is around 1/16th of a second. So it's not great, like 2-3 minutes earlier, but still, it is our anomaly predictor gives anomalies before any expert can. So the expert actually gives where is the red line, right? And MEND has given at the orange line. So we have beaten the human expert who is sitting there and analyzing in real time, right? So this can save like thousands of crores, because if you are able to save one satellite, you can save 500 crores. Yeah, so this was MEND. This was again developed with IIT Kanpur. It has a lot of applications. You can just go around and it can be used in a lot of places. And what we do here is actually we see whether the predictions are consistent, which means if somebody tells you a story about investment, right, that you're going to get this much money, and next year he's telling you some other story, and next year he's telling you some other story, probably you'll not trust that guy, right? So kind of that logic we have used here, where if there is predictions are not consistent, we set up an alert, and it has worked so far. So this is something else we did. It has huge potential again in GYAAN, in healthcare, a lot of manufacturing, anticipatory management. So this is again something that was developed by us. This was something in 2023, by the way. So very early. We developed agents were still not in vogue at that time, and we developed something called GYAAN. And the logo is the best we could do in design, right? So we are not like great at designing these kind of logos. So this is something that we are using in ISRO, which is very essential because we cannot ping data outside, and ISRO has a lot of particular lexicon. We operate with a particular language. Our data is confidential. So we needed something like this, and people are using it, and kind of it is getting better with time. And this was picked up by Bihar government. When they saw GYAAN, they wanted something like this for Bihar students, and then we are doing a project in like 27,000 schools, I guess, in Bihar with the same GYAAN modified for education. So that was very exciting, doing something at the national level. Yeah, again, this is something that we have recently done, and Professor Orayo is a great person, particularly in terms of AI evaluation. He evaluated ChatGPT-4, and he was at ISRO, and we interacted with him. Yeah, so I don't want to go into details, and this is still not complete work. We are still developing, but I request like people who are interested, AI evaluation is going to be a very big sector. Because you can put AI, but you should have clear metrics of how to evaluate AI. And for that, you need to have new measurements, which are not in any book or not in any Python libraries yet. So I think we need to start doing this. So we have just started, like, we don't wait for everybody to develop. And this is our evaluation on generality and capability. So these are like two measures for intelligence, measuring intelligence. And GPT-4 is straight up and other things like, so this is like 6 months old, by the way. These tests are 6 months old. But we are developing our own metrics even for this. So yeah, message that all these things that we have done. By the way, this is all done by 2 people. And the other one is younger than me. So basically, it's really difficult to innovate, right? So you have to get into a difficult situation. If you're at work and if you're in comfortable position, everything is going great, probably you're not going to innovate anything. It should be hard, somewhere that you have to break your head. This is my experience, maybe wrong. One thing I realized is all models are wrong, but some are useful. So you have to start with the negative thought. People say, be very positive. I'm saying, be negative. Start with the thought, everything is useless. But some things might be more useful than others, right? Like Animal Farm. So those who have read might get the reference. So all models are wrong. Don't start with great expectation, but try to do something useful, is what I felt. And when you do something useful, you have actually done tech innovation. And then this guy, which maybe the developer guy is not required anymore. So if you don't have a good manager, my idea is to become one, right, yourself. Because next is you need someone who can take that useful thing and make it a valuable thing, which is different than being useful. This is what I felt, because I have great like seniors who supported me and understood the value of that, and they used it in a way where it was valuable for the organization, not only useful. So this leads to economic disruption also. DeepSeek. By the way, I have a joke on DeepSeek, but my time is up. So anyway, let me just share it. Do you not find it funny that they named it DeepSeek? Being a Chinese company. Why did they name it DeepSeek? I will tell you, my theory is probably they were going for Seek Deep. But it sounded very Indian, like Kuldeep or Mandeep. But I think this is very relevant, right? China has done something useful, and they have come out with a model which is economically disruptive, and they have everybody's eyeballs right now, right? So this step is very important, and this step is just the next social change, which means your manager, if you're not a good person, if not an up-to-date person, right, which is very high probability in India, right? So I'm lethal, by the way, when I speak. So he will change after the economic disruption has happened, and your company will already have lost a lot of early mover advantage, right? So if you look at the development, Steve Jobs was an engineer, right? A lot of engineers, when they become managers, they are very good at that. So basically, I'm motivating everybody here to come to the second step, because I'm sure most of you are at the first step, right? And this will follow, because society generally follows economics. When you study sociology, you realize it is a study about what are the different forces on the person and what he cannot do, basically, right? So this is Bertrand Russell, my favorite philosopher, and there are some other people, right? So the secret of change is to focus all your energy, not to fighting the old, but building onto the something new. I think that is pretty straightforward. Yeah. So we are already trying to build some great Indian AI, which I cannot say today what we are actually building, but maybe in a couple of months you'll hear the news. And I would love to collaborate with anyone, talk to anyone who is interested in that. We are trying to tie up with industries. We are trying to have young people interact with us. Okay. So thank you all for listening, and I hope it was worth the time. Thank you so much.